Hey everyone, and welcome. Today, we're not going to talk about trigonometry like it's some dry chapter in a math book. Nope, we're going to treat it like the epic story it really is. It's this incredible idea that's been shaped by architects, astronomers, and brilliant scholars all over the world for, get this, 4,000 years. So, let's jump right in.
So, let me ask you something. How in the world do we measure the height of Mount Everest? I mean, you can't just drop a tape measure from the top, right? It sounds, well, impossible. You might think the answer has to be some modern tech like lasers or satellites, but the real solution? It's much, much older.
Believe it or not, the answer is ancient. It's this powerful idea that's been passed down and perfected through some of history's greatest civilizations. It's a real testament to human curiosity, and we're going to follow that journey step by step.
Okay, so our story doesn't begin with astronomers staring at the stars. It starts with builders staring at massive piles of stone. We're going all the way back to ancient Egypt, where one of the world's most fundamental mathematical needs first popped up.
Just try to imagine being tasked with building one of these things. Every single face has to have the exact same slope, so they all meet perfectly at a single point at the top. If you're off by even a tiny fraction at the base, it's a total disaster by the time you get to the peak. This wasn't some abstract puzzle. It was a massive engineering problem that absolutely had to be solved.
And the solution they came up with was this concept called the seked. Now, what's so cool about this is just how familiar it feels. The seked was basically a ratio, the horizontal distance for every unit of vertical drop. And for anyone who's ever sat through a trig class, you're going to recognize this immediately. It is, for all intents and purposes, what we call the cotangent.
And this isn't a guess. We know they were using it because they literally wrote it down. This question, pulled directly from a papyrus that's over 3,500 years old, shows Egyptian scribes solving the exact problems our architects are facing in the field. This is it. This is the very first trace of trigonometry in all of human history.
Okay, so from Egypt, this idea of relating the sides of a triangle starts to travel. It gets picked up by Babylonian astronomers and Greek geometers. But the next truly revolutionary leap, the one that really laid the groundwork for the math we use today, that happened in India.
So you had Greek mathematicians like the great Hipparchus, and they were thinking in terms of chords, a literal physical line that connects 2 points on a circle. But then, mathematicians in India during the Gupta period had this brilliant shift in perspective. They started focusing on the relationship between half an angle and half that chord. This gave them the jaya, what we now call the sine. And it wasn't a length anymore, it was a ratio, a functional relationship. This was a total game changer because it meant you could apply these ideas to any right-angled triangle, not just one stuck inside a circle.
So this is the really crucial part. Indian scholars gave us the first definition of sine as a function. They sat down and created the world's first tables of sine values. They even defined the cosine and the versine. This incredible body of work, all captured in texts like the Aryabhata, basically became the engine that would power trigonometry for the next 1,000 years.
So this powerful new way of thinking exists. How does it spread? Well, this Indian knowledge, along with those earlier Greek works, started to travel westward, and it found a brand new and incredibly fertile home in the intellectual hubs of the medieval Islamic world. And listen, this wasn't just about preserving old scrolls. Scholars, many of them Persian and Arab, took these powerful ideas from completely different cultures, laid them out side by side, and started to build something totally new. They weren't just librarians, they were innovators.
You can almost see their process right here. First, they translated and brought together the Greek chord tables and the Indian sine tables. For the first time, they could see the whole picture. Then they started to discover and define brand new functions. From there, they began proving powerful new theorems, like the law of sines that we still use all the time today. And that final step was the big one. They established trigonometry as its own, independent field of math, totally separate from astronomy for the very first time.
And this whole process led to a massive expansion of the field. What started with a simple ratio for building pyramids was about to become a complete system for understanding triangles.
This is pretty remarkable. Just look at this table. By the 10th century, the entire set of 6 trig functions that every student learns today, sine, cosine, tangent, cotangent, secant, and cosecant, was known and being actively used by mathematicians in the Islamic world. The whole toolkit was complete.
And of course, this wasn't the work of just one person. It was a whole crew of brilliant minds, each one building on the work of the others. You've got Al-Khwarizmi, who produced these incredibly accurate tables for sine and cosine.
Then al-Battani comes along and discovers the secant and cosecant. Abu al-Wafa developed complex angle addition identities, and it all kind of culminated with Nasir al-Din al-Tusi, who's really seen as the person who finally put a bow on it all and established trigonometry as its own distinct discipline.
And again, this was never just abstract math. These new tools were immediately put to work solving really complex real-world problems. Everything from predicting the phases of the moon to something crucial for daily life, figuring out the exact direction of Mecca for prayer from literally anywhere in the known world.
So when you take a step back, you can really see the incredible journey this one idea has taken all across the globe. Let's just trace that path one more time.
What you're looking at here is basically a 3,000-year-long relay of race of human intellect. It starts with the Egyptians building pyramids. They passed the baton to the Greeks, who are measuring the heavens. The Greeks passed it to Indian mathematicians who define the sine function. And they passed it to scholars in the Islamic world, who create a whole new discipline. Each culture picked it up and ran with it.
And finally, this fully formed discipline of trigonometry, a beautiful synthesis of Greek, Indian, and Persian Arabic thought, was transmitted into Europe through translations. It basically arrived as a complete mathematical toolkit, ready to become one of the main engines for the Renaissance and the scientific revolution.
And this brings us right back to where we started. That ancient Egyptian idea of the seked is the direct ancestor of the math that makes our entire modern world possible. From surveying land and engineering bridges to the GPS that's in your phone right now, the principles are exactly the same. At the end of the day, it's all just triangles.
So, you see, the story of trigonometry isn't just about math. It's about a shared human drive to understand our world, to measure it, to make sense of it all. It's a conversation that has echoed across continents and millennia, and it's a conversation that's still going on today. What an incredible journey. Thanks for joining me.